Hi everyone, welcome to Caltex Academy. Today we're looking at rationalization of fractional radicals, and our big topic of course is limits, and that is the general method indirect substitution. So this is question number 3. Somebody might be wondering, and I treated question 1 and question 2 in separate videos, and I've dropped the links of those videos in the description of this video. So please feel free and check out those videos to see what we have done there. Of course, one lesson builds on the other one. So please relax. I'll be walking you through step by step. I'll be your instructor, Julius at Caltex Academy. So grab a cup of coffee or water or any favorite drink of your choice. Sit back, relax, and to get most out of this video, please also get some piece of paper or your notebook and take some note. Pause the video and you'll get the best out of this video. So without wasting time, let's dive into the video. Now here we have a question, part A, and before we write this question, we're going to discuss 5 different questions to strengthen our knowledge in this rationalization of fractional radical. So that is why I will assure you at the end of this video you'll be comfortable with limits. If you're at high school or university or anybody taking pre-calculus, this video will be suitable for you. Now enough of the talking, let's dive into the video and have a question here. So in our question 1, it says we need to evaluate this limit with x tends to 0, and this limit is having fraction at the numerator like 1 over under root of, we have 1 plus x, then this term is subtracted away 1, so we divide the whole thing with 0. So if we are given any question of this nature, we need to first test. The first step is testing this by substituting 0 into where x is. But specifically from the denominator, if we substitute 0, then this is going to be impossible because we'll get some error. Now for that case, we're limited, we cannot substitute directly from here. So what do we do next? So the first thing here is to say that the numerator should not be having some denominator again in it, so it should be linear. Now let's go ahead and rewrite this one to a linear form by getting this number out from the numerator, and we have it as, so let's start here and have 1 over root of 1 plus x minus 1, and let's put this also over 1. Now this is our numerator, so we're going to have this numerator divided by the denominator, so we have this bar representing division and we're dividing with x, and now x also is standing on 1. Now let's get LCM of the denominator, root 1 plus x, and this 1, and we notice that is just simply root 1 plus x. So when you divide this with the first term, we get 1 times 1 is 1, and our sign is negative, so when you divide this also LCM with 1, we get the same thing, times negative 1 is just going to be the same thing here. So we have 1 plus x. So instead of division, we're just going to multiply here and reverse the denominator and numerator. So we shall have x over, 1 over x. Then we multiply the numerator separately and also denominator separately. So we realize that the numerator will not change. We just have here 1 minus under root of 1 plus x, then divide by, so it is good to write this in front here, because when you write here it's just going to look like you're multiplying x and x. So it is good practice to write this here. Just like when you have root 2 times 4, you cannot write as root 2 then 4. Somebody can mistakenly extend this and it looks like square root of 24. So to avoid this mistake, the best way is to write 4 and then root 2, and that is exactly the same thing we're doing here in the denominator. So we write x and then square root of 1 plus x. I hope we are together up to this point. If we are together, very good. Let's proceed. And for now, we have not done anything to do with the limit. We have just simply simplified the numerator and the denominator to have some number which is easier at the numerator for our working. Now with this, we can now go ahead and replace what we have inside here in our limit and start our major step. So what we need to do here is to now write the limit as x tends to 0 of this new version, which is 1 minus under root of 1 plus x. Then we're dividing it by x under root of also 1 plus x. Now here we now equate it to, so let's take a look at the numerator. Whenever in limits to get the numerator having this radical or square root sign, the first thing is to remove it. And to remove a square root sign from any mathematics, like will be you're dealing with surds or this type of radicals, what we have to do is to multiply by the conjugate. So let's get the conjugate pair of this numerator and now multiply both the numerator and the denominator by the conjugate of the numerator. So here, as our x tends to 0, now we have to write the conjugate pair of the numerator. So we start by 1 minus under root of 1 plus x. Then the conjugate of this number is 1 plus under root of 1 plus x also. Now we have to divide this and multiply the same thing with this to make our fraction here equivalent. So we have earlier on x under root of 1 plus x from the denominator, and this time I'm multiplying with the conjugate of the numerator, and that is 1 plus under root of also 1 plus x. So let's close this bracket and the main square bracket outside here, and we go ahead and do this simplification. So since the numerator is a conjugate pair, we don't have to stress ourselves. We multiply these rational numbers separately and irrational numbers separately. As we repeat our limits, we continue writing this until when we start substituting, that is when we remove this out. So 1 times 1, we get 1, and then negative times positive, of course it's negative, and we pick one of these. Remember, if you have a under root times a, also under root, this one just yields a. So putting this in mind, and since we have 2 terms here, it's also good practice to put it in brackets, since the negative will affect the signs of these numbers inside our square root when you pick it out. So let's move on and only just copy the denominator. We are not going to do anything from the denominator here. So we have under root of 1 plus x, and this is multiplied with the conjugate of the numerator. So we have 1 plus x under the root, then we close our main bracket. So here we can also open this bracket up, and after writing our limit as x tends to 0, so the first term remains as 1, and this one goes to -1, and of course negative and positive, if you multiply them you get negative. So we can also recopy our denominator, and we have there x under root of 1 plus x times 1 plus under root of 1 plus x again. Then we close our bracket up. So now the good news here is this square sorry, this negative 1 and positive 1 will cancel. Now let's clean up that mess by rewriting it again down here, and we're left with negative x from the numerator, so we can rewrite it in terms of a factor. So how will it look like in terms of this factor we're talking about? So we can say here this is the same as negative 1 times x. So as usual, we also rewrite our denominator here, multiplied by 1 plus under root of 1 plus x. So we also check out that, okay, this x from the denominator will divide the x from the numerator and it cancels out. So if we finally cleans it up, we'll obtain our numerator as a rational number because the root sign will have disappeared. So as x tends to 0, the numerator will just be negative 1 and denominator will just be under root of 1 plus x times 1 plus into 1 plus also x. Now when you look at this one, we can now do our substitution without any problem. Let's exactly do that. So we remove the word limit and x and just replace any x with 0. So here we have our negative 1 over under root of 1 plus, now x is 0, we multiply it with 1 plus under root of, also our 0 here is replacing x. Then we can move on and simplify them. So how do you simplify? Of course, we add 0 to 1 and we get 1. So the square root of 1 is just 1. So this term here simplifies to 1. Then we move on inside here. We have 1 plus the square root of also 1 here is 1. Then we add it together. So if we simplify everything, we'll have here 1 plus 1 from the bracket is 2 times 1 outside here, we still get 2. So finally, our question which was limit, this implies that when we have our limit as x tends to 0 of our original function, and that function is 1 over 1 plus x and the root minus 1 all over x, and we simplify it over, realize that this is gonna be our answer. So proudly we'll roll our answer here, and then we see whether we have understood or not. So please, if you have not understood, don't worry so much, because I have 5 good examples for you. We have just done 1 and we are left with 4. The process, I know you understand everything very well. But if you've also understood, in our next question here, please try to pause the video, work it on your own, and then sit back, look at us working together, and you compare answers. If they're all together and the same to mine, and then you just give yourself thumbs up. So let's move on to the next board to see the second question. Now in our second question, WAEC says you need to evaluate limit as x tends to 4 of 1 over root x minus 1/2 over x minus 4. as we have done before, we can also go ahead and make sure that the numerator is just not having also another denominator on top there. Just like what we have done before, we shall just rewrite this one as 1 over root x minus 1/2, and we know this is our numerator, so let's divide by our denominator, and our denominator is having x minus 4, so we can make this one stand over 1, and we obtain the LCM of 2 and root 2 as 2 root x, sorry, not root 2 but root x. So when you divide the LCM with this, we get 2, and times 2 we also get 2 here, minus 2 root x divided by 2, the 2 will cancel, and we shall be having only root x times 1 is also root x. So instead of dividing, we are multiplying. So we have here the numerator is now 1 and denominator has just swapped down from the numerator. So multiplying the numerators and denominators differently, it will yield for us, of course multiplying by 1 will have no effect, so we have here 2 minus root x over the denominator, we have here 2 root x times x minus 4. So you don't need to open it up, they just leave it like that, and that is the next version of our first part here in this question. Now for now we have not done anything yet, we just only worked what is inside the square bracket in a different form. So here let's move on and see how we can work it out. So we have limit as x tends to 4 of, we write our new version, and that is 2 minus root x divided by 2 root x multiplies x minus 4. So how is this gonna be? So what we do here, since we know that the numerator is already having some radical or insert form, what we have to do is to multiply that numerator with the conjugate of the denominator, and also multiplies the denominator with the conjugate of the numerator. So let's move on and just do that. So from here we have 2 minus root x, and this multiplies its own conjugate, that is 2 plus root x. As we have done that in the numerator, let's do the same to the denominator. So we have 2 root x, and then we have x minus 4, also multiplied by the conjugate of the numerator, and that is 2 plus root x. And we close our general bracket here. So for the conjugate pairs, we'll multiply these real numbers together, and we multiply the numbers under the root also together. So the first number here goes to 4, negative times positive is negative, and then this will just be x, because x times x, and the root will just be that, and we don't have to tamper with the denominator, just copy root 2 under this x, then we multiply this one here by x minus 4 multiplies by our conjugate from the numerator, so we close our bracket also here. Now the next step is to see that when we study carefully, we'll see that in the denominator we have something x minus 4, meanwhile the numerator we have 4 minus x. They're exactly the same, but in alternate position. So what we have to do is to rewrite the numerator such that it is exactly like the denominator for us to cancel out, because from testing here we realized that when we replaced 4 in this x, the bracket will vanish to 0. It will just make the whole denominator to 0. So to avoid that, we need to make sure this term goes away. So since the numerator is looking somehow similar, we can rewrite this 4 minus x as -1 times x minus 4. In that, if you open up this bracket, you will obtain exactly what we have here. So rewriting that one here, we shall have our limit as x tends to 4 of, so we have here -1. This multiplies x minus 4, and we divide with our denominator, which was 2 root x multiplies x minus 4 times 2 plus root x. Now we can go ahead and divide this together so they cancels off, and we can brush it off clean by taking out those crosses, and we see that we have already a rational number from the numerator, which gives us a smile on our faces, because we know there's nothing that is going to make it undefined or that can give us a match error. So we have 2 root x multiplies by 2 plus also root x. Next is just making our substitution when x tends to 4. So as we're substituting 4 to this expression, we remove the word limit and this x away. Therefore, -1 from the numerator will divide by, we have 2 root 4 multiplies by 2 plus root x, and for our case x is now 4. So we can move on and continue to simplify. The term outside here, this scalar is now root 4 is 2, 2 times 2 is also 4, and that multiplies by our 2 here, and square root of 4 is 2. So we can work inside this bracket and we obtain 4. This 4 multiplies also 4. So when we multiply that, our final results will be, of course, this implies that limit when x tends to 4 of our original expression, which was 1 over root x minus 1/2 divided by x minus 4, will straight get -1 over 16. So if you tried it before and have got the same answer, like -1 over 16, and you are in the right track. So thank you very much for doing that. And please, before you proceed to the next number, if you have not subscribed to the channel, please spare some 3 seconds to subscribe to the channel, like this video to post it to many people, and at the same time also you share with your friend, let your friend also benefit from these videos. So without wasting time, let's move on to the next question. In question 3, we have limits as x tends to 1 of From the numerator, we have 1 over x plus 3 minus 1 half, and we divide the whole thing with x minus 1. So this one is somehow similar to what we have done in the first one, but it's slightly a little bit different. So let's try by substituting our x with 1. So if you place x here in the denominator, of course it goes to 0, so it's not possible to work that way. Now we can go in the way we knew. Let's pull out the numerator, and in the numerator we have just 1 over under root of x plus 3 minus 1 half, and as before we can divide this one here with our denominator, which is x minus 1, and this is also standing on 1. So getting our LCM, we now have 2 times root x plus 3. So we can move on and see that when you divide this LCM with this first denominator of this first number, we get 2, and 2 times 1 is 2. So this one goes root x plus 3, then times 1 over x minus 1. So when you also simplify by multiplying the numerators separately and denominators separately, we obtain 2 minus under root of x plus 3. From the denominator, we just simply combine the two expressions together, and we have x plus 3 times x minus 3. But this could be beautifully written when we have this one somewhere here. Now we can arrange that in our next part here. Okay. So writing this as limit as x tends to 1, we can now write this new version of our question, which is 2 minus under root of x plus 3 divided by, so let's bring this one in front, and we have 2 x minus 1 times under root of x plus 3. So this is gonna be equals to, we multiply the conjugate of the numerator in both the denominator and the numerator itself. So as x tends to 1, the conjugate pair of the numerator would be 2 minus under root of x plus 3 times 2 plus under root of x plus 3, and this divides the denominator, which is having 2 times x minus 1, and we have here x plus 3 multiplies the conjugate of the numerator, that is 2 plus under root of x plus 3. Here again at this stage we can move on and simplify the numerator as we maintain the denominator just like here. So as x tends to 1, from the numerator we'll multiply 2 and 2 to get 4 minus the two numbers inside this, so we shall put them in bracket, and we have x plus 3, and then we just recopy our denominator without altering anything. So we have x inside this bracket, and we multiply it by root x plus 3, and then also by the conjugate of the numerator, x plus 3 under root. The next stage is to expand our numerator to get ways in which we can eliminate something from the numerator with something from the denominator here. So let's move on and see that this negative affecting the first sign from the first number, that is x, to negative, the same to the second number here, that is 3, and we divide this one by 2 into x minus 1, again with x plus 3 and 2 plus root x plus 3. Now here we can continue simplifying the numerator, in that let's first write what is here in our limit. So 4 minus 3 we get 1. You can bring to the center maybe minus x. I just want to place it in a bracket because I'm seeing something similar from the denominator here, and that is 2 times also x minus 1 and under root of x plus 3 multiplies by 2 plus under root of x plus 3. Now here we'll see here that 1 minus x will cancel out both from the numerator and the denominator. Now we can move on and rewrite the remaining terms. Of course it cancels to 1, and here of course 1, so 2 times 1 is 2 times this will remain the same thing here. So we can just brush it up by writing what is remaining as x tends to 1 of, from the numerator we just only have positive 1, and the denominator has reduced by 1 term, so we have here 2 times we can say root x plus 3 multiplies 2 plus root x plus 3, and close our bracket up. Now since the numerator is already a rational number, we can go ahead and make our substitution of x to our function here. So the numerator is having 1 and denominator is having 2 times x, which is 1 plus 3 multiplies by 2 plus root of also 1 plus 3, and we continue simplifying. So the numerator remains as 1. Now here 1 plus 3 is 4, and the square root of 4 is 2. 2 times 2 is also 4. So this term is 4, and then we have 2 plus also now 2, because we have here 4 under root, which simplifies to 2. So when you work out the bracket first, you realize we have 4 times 4. Therefore, the limit as x tends to 1 of the original version which was 1 over x plus 3 minus 1/2 all over x minus 1. When you simplify it, you just get 1 over 16. So this is our solution for question number 3. If you have paused the video before and you tried it on your own and the result is like this, thank you very much for that, and then give yourself a thumbs up. Congratulations. So let's dive into question number 4 in our next question here. Well, question number 4, we're left with just 2 questions, number 4 and 5. So how is it looking like? Okay, take a look, see it carefully. X is tending to 0, and what we have here is 1 over root of 4 plus x, then minus 1/2. Oh, almost looking like the third question, but then the difference is in the denominator and what is inside this root sign. Okay, I think this one is doable, so you can also go ahead and pause this video and then try it on your own and come back or continue with the video to see how the answer will look like. So as usual, we can pick out the numerator of our expression, and that is 1 over root of 4 plus x minus 1/2, which of course we're dividing it by the denominator, and that denominator is only x. This will be standing over 1. Now getting our LCM, x is 2 root 4 plus x, dividing here, multiplying by 1, we get 2, minus dividing this by also 2, we get root 4 plus x times 1 over x. Simplify the numerator, we get 2 minus 4 plus x over 2x multiplies 4 plus x, and this is our new version, which we shall just use it to replace what we had earlier on here. And we have our limit. Maybe let me scroll it up a little. Yeah, there is fine. X tends to 0, and our new expression is 2 minus root 4 plus x under root. Of course, so we have here 2x multiplies 4 plus x under root. So how will this work? Simple. We can move on and recopy our unit. We recopy the limit as x tends to 0 of, the next thing is multiplying the numerator and denominator by the conjugate of the numerator, and the conjugate is 2 plus under root of 4 plus x. So we go to the denominator and we have 2x into 4 plus x under root multiplies 2 plus 4 plus x, then we go ahead and simplify the numerator, maintaining the denominator as usual. So x tends to 0 of the function we have here 4 minus into 4 plus x from the numerator, and our denominator remains the same, so we only simply copy it down here, plus x times 2 plus 4 plus also x under root. Then we can move on and open up the bracket from the numerator, whereby x tends still to 0, and when you open up this bracket we have negative 4 minus x from the numerator, and denominator we have 2x and the root of 4 plus x, then times 2 plus under root of 4 plus x, and again here we have 4 disappearing. Now we can rewrite the numerator factoring out negative 1, because we are seeing something here, x from the denominator. So we have the limit as x tends to 0 of the numerator as negative 1 times x over 2x multiplies under root of 4 plus x, then times 2 plus under root of 4 plus x. So looking at that scenario, I think we can also cancel x from the numerator and x from the denominator. So rewriting the remaining terms from the numerator, which is negative 1, we have limit as x tends to 0 of negative 1 over 2 multiplies by under root of 4 plus x times 2 plus 4 plus x. Now at this stage, since our numerator is already a rational number, we can substitute 0 to replace all x from our expression, starting with 2 multiplies with 4 plus 0 times 2 plus under root of 4 plus 0. Now this one is going to be negative 1 all over 2 times square root of, cos 4 plus 0 is 4, square root of 4 is 2, then multiplied by 2. Okay, maybe we can use a different color here because it might confuse us. This is fraction, part of the conjugate from the numerator, so this is going to be also what, 2. Now we can move on and simplify those together and see that negative 1 divided by, so this one simplifies to 4 times also 4. So 4 and 4 give us negative 16, and that is from limit as x tends to 0 of the original expression that looked like 1 over under root of 4 plus x, then minus 1/2 all over x, and we can close our bracket here. It gives us that solution. Now again, if you try this on your own and you have got the same result, big up to you and thank you for trying also. So lastly, let's go and look at the last number, 5. In our number 5, we have a question that is limit as x tends to 9 of 1 over root x minus 1/3 divided by x minus 9. So again, if you're already okay, you can move on and simplify this number on your own to see what answer you'll obtain before continuing with this video. That is perfectly fine. But if you think we still need to move together, don't worry, also it's okay, we can continue together. So as before, from the previous questions, we can write the numerator dividing it with our denominator, and that is x minus 9, dividing it with 1, because any number is always over 1. Getting our LCM, we have 3 root x, dividing it over, this one will go to 3, then 3 will go, so we shall have here root x. So multiplying by 1 over x minus 9. Multiplying them, we have 3 minus root x over 3 root x times x minus 9. So that is the new version of what we have inside here. We can replace the old version with the new version here. So here, let's move on and write our limit as x tends to 9 of 3 minus root x divided in by 3 root x times x minus 9. So we can go ahead and make sure that both the numerator and denominator are multiplied with the conjugate of the numerator. And what is the numerator? Is 3 minus under root of x times its conjugate is 3 plus root x divided by, so we have 3 root x, we are multiplying it by x minus 9, also with the conjugate 3 plus root x. So let's move on here and multiply the numerator and maintain the denominator as before. Then we have limits as x, that means as x tends to 9, we have here 9 minus x all over 3 root x times x minus 9, then 3, we need to close that bracket up, and then plus root x and also this bracket is closed. So this one is similar to one of the questions we look at the on, where we have 9 minus x, yet we had a denominator as x minus 9. So we can reverse our 9 minus x as negative multiplied by x minus 9. So let's move on and replace that number from the numerator. So limit as x tends to 9, we shall have negative into x minus 9, divide it by 3 root x times x minus 9, then 3 plus root x. So from here we can now go ahead and cancel the numerator here. This one goes of course to 1, then the denominator also vanishes to 1 times this. Of course will remain the remaining terms there, which we are going to collect together to make sure that we have rational number from the numerator, and our rational number from the denominator, from the numerator is negative 1. So we have here limit as x tends to 9 of the numerator negative 1 divided by the remaining terms from the denominators are 3 with x, then 3 plus root also x. So we can close up this and make our substitution, because the numerator is already cleaned up, and we have negative 1 divided by 3 and the root of 9 times 3 plus under root of also 9. So we can see from here clearly that square root of 9 is 3 times 3 is also giving us 9. So we have from the numerator as negative 1 divided by 9 from the first number, and the second number is square root of 9 is 3 plus 3, we have 6. So the denominator is 9 times 6. So if you multiply 9 by 6, you get 54. So generally our result is negative 1 over 54 of the expression if we had limit of x tending towards 9 of the function, because we write the original 1 over under root of x minus 1/3 of x minus 9 is the one that gives us these results here. Again, if you try it on your own and you've got something similar, congratulations for doing that. So if I've not got it exactly like this one, don't beat yourself up. Go again and watch the video, pause where necessary to see that you get all the concepts clear, and then you will be good to go. And if you have watched up to this time, thank you very much for supporting this channel. Please come again next time for the upcoming videos that I'm going to be posting here every day. And remember to share this video. If you have not subscribed, you can do so to subscribe, and see you in the next video. Ciao.